So in this video we will learn the very basic thing of structural analysis, that is your static equilibrium. Okay, so we will learn static equilibrium. So before learning the static equilibrium, as an engineer you should think, or you should ask, why you should learn this static equilibrium. Whatever you are going to learn, always try to ask yourself two questions. First question is what you are going to learn, and second one is why. Okay, so the first question is, today we are going to learn static equilibrium. Okay, but why? Well, the very basic job of a civil engineer is that there is a structure. Let's say this is a structure. Okay, and to this structure there is a threat. Let's say this is a storm. Okay, so storm, or this is a wind. So this is the threat and this is the structure. So combining these two things, you will get a response. Okay, so combining these two things, you will get a response. That means there in this structure there will be some stress or internal force and deflection. Okay, so you always, as a civil engineer, design this structure to carry this internal force and to maintain a controlled deflection. This is the very basic duty of any civil engineer. Okay, but to know these internal forces or the reactive forces due to this external stress, you need to learn first this static equilibrium. Okay, so now it's clear to you what you are going to learn and why you are going to learn that. Now, before learning static equilibrium, you need to learn some prerequisite thing like the degree of freedom and support reaction. So now start with the very basic thing, or the very first thing, that is your degree of freedom. Okay, so what does it mean by this degree of freedom? Okay, so let's take anything. Let's take a bar like this. Okay, and it is in space. Okay, let's say it's in space. So if you apply a load like this in this direction, it will move in this direction. If you apply a load in this direction, it will be displaced to somewhere here. Now let's say you are applying a rotation. You try to rotate this object. Well, it will rotate like this. Okay, that means when something is in space, it is free to move or rotate, or we can say more technically, it's free to translate. Okay, and also it's free to rotate when it is in space. Okay, that means when it is in space, if we take a three-dimensional space system, so it can move to the, when I am talking about translation, it can translate into x direction, into y direction, in z direction. And also if I talk about rotation, it can rotate about your x-axis, about your y-axis, and also about your z-axis. Okay, so in 3D space, any object have total 6 degree of freedom. Okay, so now it's clear to you what is degree of freedom. Now if I talk about 2D system, so of course in 2D system there is no z-axis, so there is no translation along z. So for 2D there is no translation along z, and also there is only rotation about your z. There is no rotation about y or x. So in case of a 2D system, there are three. Okay, there are 3 degrees of freedom along x-axis, along y-axis, and there is one rotation that is about z-axis. Now again compare a body. Let's say this is your body, this is the body 2D, this is your 2D body. Okay, and there is no restraint, it is simply placed in a 2D system. Okay, this is x and this is your y. Now apply any threat or any force. Threat in structural engineering is nothing but force. What will happen? Well, it's quite obvious, it will be displaced somewhere here. Clear? There is no doubt in it. It will simply be displaced by some amount of x and it will be rotated about your z-axis. Okay, so the final position after application of this load will be here. Now let's say this is your building you have built. Now there is a strong wind or a small amount of wind and your building becomes like this. Is it desirable to you? Of course not. You are spending $1 million, sometimes $1 billion to build your dream skyscraper, or you simply build your dream home. So obviously it is not wanted that it will be collapsed like this. So what you do, you simply, let's say this is the structure you have built on the ground. Now what you do, you simply put some restraint like this. These are the restraint. Okay, now let apply your thread, whatever may be the thread. Let's say you are applying a load like this. What will happen? Well, it will deflect. Genuinely it will deflect, but it will not collapse like this. It will stay in its own place, and that is desired by any engineer. We limit this deflection, control this deflection, where in this case the deflection was uncontrollable. Okay, and when you are applying or when you are providing this restraint, what you are doing? Well, you are taking away the freedom of this structure. Okay, if there is a people in this world and if you are trying to take away his or her freedom, there will be mutiny. But in case of structure, it will not happen. We want that the structure will have less number of freedom. Okay, so simply by putting some support, we are decreasing the degree of freedom. Okay, so initially in this case, this was our body. Initially the degree of freedom was 3. Of course it is a 2D system. Now what we have done, we have fixed it with your ground. Okay, now it cannot move towards x, cannot move towards y. Okay, this is x direction and this is y direction. So along x the movement is closed, along y movement is closed. Not only that, along z axis it cannot rotate. So now the degree of freedom of this system is reduced to almost 0 at this point. If we take 2 points of this structural element, about this point there is degree of freedom equal to 0. Okay, and this type of support is known as your fixed support. Okay, so what we do in case of a fixed support, we simply fix the structural member. Again I am repeating, we simply fixed it, maybe by complete casting, monolithic casting, or by providing your fixed joint, okay, or moment connection. So here it is represented by the symbolic represent is either this or this. Okay, this is known as your fixed support. Okay, Now you may think that I have started my lesson after saying that I will discuss about static equilibrium, okay, and now I am talking about support. Well, for your information, to know the static equilibrium, you need to know both degree of freedom as well as the support and support reactions. Okay, so now it is clear to you that in case of a fixed support, there is degree of freedom equal to 0. Okay, so now if let's say this is the body, okay, now you are applying a load, well, it will move. But suppose if this is the body and you are applying a load, but here you are standing here, one hand supporting this object, okay, so what will happen? Of course you will feel a force or pressure, isn't it? And that pressure that you feel is known as reaction. Okay, when there is no support or no restraint, there is no question of reaction. But when you resist the object, obviously there will be some reaction. So in this case, here initially the body was like this. It was moved in x direction, it was able to move in y direction, also it was able to rotate above z axis. Now you have stopped x direction movement, so of course there will be a reaction force in x direction. Okay, not only that, in y direction you have restricted the movement, so in y direction there will be a reaction force. Not only that, also in case of rotation about z axis you have restricted that. Okay, so there is a reactive moment also about z axis. So in case of fixed joint, there are 0 degree of freedom but 3 reactive force. So always the summation of degree of freedom and your summation of reactive force is constant. Okay, so initially the degree of freedom was 3, reactive force was simply 0, so it was 3. Now degree of freedom has become 0 and reactive force is 1, 2, 3, so 3, it is 3. Okay, so is there only one type of support exist in real world? No, not at all. There are many type of support exist, many complex, but 3 simple support I am going to discuss. First one is fixed support. Well, you have already learned about it. Now go to the next support, that is your pinned support. What is pinned support? Well, this was your structure, okay, this was your ground. Now instead of just totally sealing the object with your ground, let's provide a support like this. This is a support and drill a hole within this object as well as within the support and put some pin. Okay, what will happen? Simply it will be able to rotate about this pin. Okay, so if we talk about degree of freedom, we have 1 degree of freedom, which is the moment of z, or movement or rotation about z is allowed. So simply your reactive force mz is 0 because no one is resisting you to rotate. Okay, so there is a degree of freedom in this about z axis. Okay, so degree of freedom is 1 about z axis, that is rotation is allowed, that's why reactive force is 0. Now if we apply this body, a load is applied on this body and this support is fixed with ground, there is pinned support or pinned connection, so it cannot move towards this direction or x direction, and it cannot Move means there is a reaction, so along x-axis there is a reaction. Okay, so it is not equal to 0, and degree of freedom along this x is 0. Okay, similarly in this y direction it cannot move because it is fixed with your ground, so degree of freedom is 0, and reaction in this y direction is not equal to 0. Okay, and this pin joint is expressed like this. Okay, this is the structural member, and this pinned joint is expressed by this symbol. Okay, the third support is this one, which is known as roller or sticky roller. Okay, sticky roller. Why? Well, rollers mean it will be something like a wheel, okay, rested on ground, clear, but it cannot move towards y direction or upward. When you apply a load on the object which is seated upon this roller, okay, let's say you are applying a force in this direction, simply it will move towards this x direction, it will move, but towards y direction it cannot move. Also, let's say you are applying a moment like this, okay, of course it will be able to rotate like this. So for this roller support the moment is allowed, so there is no reaction. Moment is equal to reactive force, moment is 0, because along this z axis your rotation is allowed, rotation allowed, so no reactive force. But towards y direction, movement towards y direction is not allowed, so there will be a reactive force, that is Ry, which is not equal to 0. And also towards x direction your movement is allowed, this is allowed, so reaction is 0. Okay, so now you have learned what is degree of freedom and what is your actually support system. Simply, if when the supports are not provided in any structural object, it has some degree of freedom. Okay, whenever you have applied the support, it will have less degree of freedom. Okay, so initially it was your object, no support, reaction is 0 in each cases. Okay, degree of freedom is full 1 1 1. Okay, first one is, let's say, for direct movement in x direction, this is movement for y direction, this is rotation about z axis, and this reaction force for towards x direction, towards y direction, and about z. Okay, now let's say you have put a roller, so it will have degree of freedom along x, yes, along y, no, rotation is allowed, yes, so reaction along x 0, y yes, and about rotation, yes, there is no reaction. Okay, now again about your, let's divide them. Now what about your pin support? This is the pin support. Well, towards x no movement allowed, towards y no movement allowed, and what about rotation? Yes, rotation is allowed. So reaction, of course, for x direction it will have reaction, for y direction it will have reaction, but as rotation is allowed, no reaction will be there. Now what about fixed support? Here movement towards x is allowed, no, towards y, no, rotation no. So there will be three reaction. This is for reaction towards x, towards y, and a moment reaction. Clear? Now I will discuss about another topic, that is your free body diagram. Okay, what is free body diagram? Well, from the name you can assume that there is something which is free. So well, this is the body and it will have some support. Let's say at one end there is pin support, at other end there is roller support. When I am talking about the free body diagram, actually I am talking about the support free body diagram. Support free body diagram. So what is this? Let's say this is the beam. You know what is beam? Let's say this is the beam and this is pin support, this is roller support. Why I am talking this is beam? Because beam is a structural element where load are applied transversely. Okay, transversely applied load. Clear? That's why it is known as beam. And if I tell you you have to draw a free body diagram, so first thing is you have to make this beam support free. So this is the beam. Of course I have not drawn any support, but that doesn't mean that they don't exist. Okay, you have applied a load like this. Let's say this is P at a distance of A from support A and at a distance of B from support B. Okay, so as there is support existing, in real case of course there will be some reactive force. Well, for field case, you know, there are two reactions, in x direction and y direction, and for roller there is one reaction. So this is the direction in y direction, because for pinned in y direction movement is not allowed, also in x direction movement is not allowed. So this is the reaction in x direction, this is the reaction in y direction. In case of roller there is only one reaction, that is towards y. Let's name it. For support B, this is, let's say, B and acting towards y. This is for A acting towards y, and this is reaction at A acting towards x. Okay, now let's say U, let's say this is U. Okay, don't mind for your figure. Let's say U, this is U, and this is your sister. Okay, please don't mind. And both of you are standing at two ends of a plank, and the plank is rested on an edge like this. Okay, now what will happen? Let's say your weight is W1 and the weight of your sister is W2. Simply, if your weight is more, it will be like this. Okay, but if your sister's weight is more, in that case it will be like this. In both cases you will be hurt, you or your sister will be hurt. So it is desired that the weight of both of you are equal. In that case this system will be in balanced or in equilibrium. Okay, so this is the concept of equilibrium. Equilibrium is a state of a mechanism where there is controlled deflection. If the system is not in equilibrium, this deflection which in this case is this much, too much high or too much. For this side this is too much. Okay, so if it is in equilibrium, you have controlled deflection. This is the concept of equilibrium. So now instead of you and your sister, replace this beam. Okay, this is the beam. Now you have applied an external load. Okay, and you have some reaction like this. Okay, this is the external reaction or internal forces, whatever. So if this external force is not equal to this internal reaction, of course this beam mechanism will not be in equilibrium. So to maintain equilibrium, always you have to make sure that the summation of external force is equal to summation of internal force, or external moment is equal to summation of internal moment. Okay, so in this case of beam, what is the external force? This is P. And what are the external force? AX, AY, BY, all are external. Sorry, these are external force and these are internal force. Okay, so now in which direction you are considering this equilibrium, you have to follow this equation for that particular direction only. Okay, so let's say again consider this is the beam. Sorry, this is the beam. Okay, this is support and this is the applied load. Let's say this is A, this is B, this is B. Okay, the free body diagram looks like this. This is your free body diagram. You have only load, external load and internal reaction. That is A, that is B, it is AY, AX, and this is BY. Now let's say first we are considering equilibrium in X direction. This is X direction, this is Y direction. Okay, and we have moment about Z axis. So what about equilibrium in X direction? Of course, the total summation of external force towards X is equal to summation of internal force. This is external, this is internal towards X. So towards X axis or X direction there is no external force, so this is 0. But internal forces, yes, we have AX. So from this equation it is clear that AX is 0. Now next about Y direction. This is a 2D system, so we have to consider only 3 possibilities: movement in X direction, movement in Y direction, and rotation about Z axis. Okay, so now movement towards Y direction. While to maintain equilibrium, forces in Y direction, external forces in Y direction must be equal to internal forces in Y direction. So what is the external forces? Y direction, that is P. Well, we are taking everything positive for upward, for towards right positive, for clockwise this is positive, here this is downward, so this is negative. Negative P is equal to, here this is AY, this is BY. This is one equation. Okay, now the third one, that to maintain equilibrium about this Z axis, or to maintain equilibrium of rotation about Z axis, the external moment about Z axis is equal to internal moment about z-axis. Okay, so external moment, while there is no applied external moment. Okay, and always moment are taken about a point. So let's say here we are taking about point A. Okay, so about point A, what is the external moment? Well, P times A, sorry, it is not 0, this is your P times A, and it is acting clockwise manner, so positive. This is equal to internal moment, while we don't have any internal moment, so it is 0. And external moment of course will be also produced by this force also, so this is positive, and the moment produced by this By about point A is minus By times A plus B. The distance lever arm is A plus B. This is equal to internal moment. We don't have any internal moment reaction, that is 0. So from here also we can get another equation. So from these three equations, this is equation 1, this is equation 2, and this is equation 3, we can get 3 unknown, 1, 2, 3. Okay, so this is the requirement of civil engineer, which I have discussed at the very first. We need to find the internal forces and deflection. So to find these internal forces, we can use these three equations which have come from the concept of equilibrium. Well, so that's all for today's lesson. We have covered what is degree of freedom, different types of support, and from that we have derived the condition of static equilibrium.